We will start with the problem related to the shear reinforcement. So first of all, we'll write down a problem. So a problem is a simply supported beam 300 mm and 600 mm effective depth carries a uniformly distributed load of 74 kilonewton per meter, including its own weight over an effective span of 6 meters. Over an effective span of 6 meters. The reinforcement consists of of 5 bars of 25 mm diameter. Out of these, 2 bars can be safely bent up. At 1 meter distance. From the support. Design the shear reinforcement. For the beam. Use M20 grade of concrete and Fe415 grade of steel. So this is the problem, and we need to design it for the shear reinforcement. So we'll be going through the solution. Its beam depth is 600 mm, width is 300 mm. Effective span is given 6 meter, as well as the UDL is given 74 kN per meter. It's already we have provided 5 bars of 25 mm diameter, and 2 bars can be safely bent up at 1 meter distance from the support. So this is the data. So first of all, we'll calculate the factored load. So factor load WU, it is 1.5 times W, which is equals to 1.5 into 74. This is 111 kilonewton per meter. And since this is the simply supported beam, so we can say maximum shear force for which we need to design the shear reinforcement. So maximum shear force Vu max equals to WL by 2. So this is 111 into length is 6 divided by 2. So you will be getting here around 333 kilonewton. That's the maximum shear force. So now it is that the critical section for the shear, you can say, which is occur at the distance of effective depth. So from the support, so let us assume the effective width of the support, if it is 4 mm, so we can calculate ds. So if we just assume width of support divided by 2 plus effective depth plus depth of the beam. So this is the distance what we require at the critical section. This is for the critical section. So width of support, so let us assume it is at 400. So 400 divided by 2 plus depth of the beam is 600 mm, which is given in the problem. So 600, which is almost 800 mm. Now this is from the center, you can say. So this is the ds is the critical section depth. Now we can calculate design shear now. So design shear, it is given by VUD. So design shear will be equals to whatever maximum shear force we got, that is VU max, minus we need to just deduct the, so let us have this is the beam. So from this distance you'll have this critical section, and there's a ds distance, okay, and here it is already the load is acting, say WTU. So we need to just deduct this distance so that we will get the design shear. So VU max minus will have this WU into ds, this is equals to 333 minus 111 multiplied by 0.8. So if we calculate here, we will get it around 244.2 kilonewtons. So that's it. Now to go ahead with the calculation, we have the clause 40.1. So clause 40.1, what does this suggest? This is the nominal shear stress, this is tau V into VU by BD. This is on page number 72. So this we will go ahead with. We'll calculate the nominal shear stress for the shear force whatever we got. So now from clause 40.1 page number 72, we got this tau v which is equals to VUD divided by BD. VUD we got here 244.2 kilonewton. We'll convert into Newton divided by BD. Width is 300 mm. This is given 300 mm and 600 mm. So 300 by 600, we'll get it around 1.36 Newton per mm square. So this is the nominal shear stress what we got. From the clause number 40.1 page number 72 we got this criteria. Now we know that in the problem it is given that there are total 5 bars of 25 mm diameter, and out of these 2 bars can be safely bent up at the 1 meter distance from the support. So remaining 3 bars would be at the support, right, and 2 bars would be bent up. So 3 bars would be at the bottom and 2 bars would be at the top. So we can just calculate that AST, so that we'll calculate the next one would be to check. Now we have this criteria of minimum shear reinforcement. So we need to just check whether this tau v is less than tau c. Now tau c, how to calculate tau c here? So tau c, it is the design shear strength of the concrete, that is from the table number 19. So this is according to the table number 19. We will get the tau c. It depends upon grade of the concrete and percentage of the steel 100 AS by BD. We have M20 grade of the concrete. Once we got this, we will get the tau c, and depend upon the tau v and tau c, we need to then calculate the shear strength, shear reinforcement. So we can just go ahead with the calculation of the, let us consider this as your step number 1. So this is our step number 1 to calculate tau v. Calculation of tau v. Now in the next step we will be calculating the area of the reinforcement